Okay, so this is a lesson on the cosine law. I've been hinting at this for quite a while for some of you guys in physics. This is one of the most important rules that we have for being able to solve trigonometry problems. And so I'm sorry I can't be here today. I hope this video lesson will help make sense. Basically, after this lesson, I'm actually done teaching you stuff until Christmas. So the plan from here on out is we're going to do cosine law lesson today. And then on Friday, Monday, and Tuesday, I'm going to give you guys some work time to hopefully finish your assignment. You should be able to get almost all of it done. And then on Wednesday / Thursday, then I'll give you guys your first quiz for the unit. Friday we really won't have school because we'll be doing the talent show and the banquet, and so we have about a week left till Christmas. And in that time, I want to accomplish this lesson, finish the assignment, and finish a quiz. I mentioned to you guys before. Then when you guys come back from Christmas, we'll do one more lesson. It'll be on what's called the sine law. We'll just add one more law into it. And then we'll also end up doing a project, which I talked a bit about, where I'm going to have you guys search for angles and triangles and try to search for your own real-life questions, kind of like what I try to do when I make examples. And we're also going to try to finish one more quiz and one more unit test. Ideally, we should be done this trigonometry unit by just probably it'll take a whole week after Christmas, plus a little bit extra, I'm guessing. And so then after that, we'll have about a week to study before we finish classes, and that'll be it. And so just a word to the wise then, please don't leave your assignment till the last minute, because we are going to be rushing to get other things done. So when we're finished this lesson today, make sure you're still working on as much of it as you can. You should be able to do almost all of it now. There's only a couple of questions that absolutely require the sine law, which is the one topic I won't have shown you. So you should be able to solve almost everything. So let me talk you through the sine law. Let me give you an example here. Imagine you have the reclining chair, which we talked about in a previous day. And this reclining chair, I hope this pen shows up nicely. Let's go with purple. Purple should be nice and bright. The angle of this chair right here, the standard position angle, would be 150 degrees. Okay. Which means that if you were to continue backwards like this, pardon all the clicks in the background of my mouse. I don't have my little tablet, so I'm using my mouse today, so this will be a little less neat than normal. That reference angle is 30 degrees, and I really need you guys to know that terminology, especially for when we move on to grade 12 trigonometry. So I'll just abbreviate this as the standard position angle, the SPA, and this is the reference angle. Please know that terminology. Okay, so here's the question then. What happens if I want you to calculate this distance right here? Let me try to draw it in nicely. Crayon? No, I just want a normal pen. There we go, red. So what if I wanted you to find this distance right here? So here's the problem with finding this distance right here. I don't have a right angle triangle. And that becomes a huge issue because all of the rules that we've learned are for right angle triangles. So I'd like to show you a way of solving this. And then after we solve it this way here, I don't ever want you to solve it this way again because it's so much more work. But here's what you could do. You could make a different triangle right here in the corner. And this one would be a right angle triangle. And we know a couple pieces of information here, so let me try to plot these nicely onto our graph here. Let me go with blue for this information. It says that the chair has a length of 104 centimeters, and that was the back of the chair. So this right here is 104. This hypotenuse side of the right angle triangle. And I also said the base of the chair is 76. So based on some triangles, I could actually solve for this y value right here and this x value right here. Now you'll notice I've changed the wording here from sometimes. Sometimes I put in the word exact distance. When we use the cosine law, though, we usually skip exact distances, and as unfortunate as it is, we actually have to round and use decimal numbers. So we're not actually going to go with exact values, although sometimes we could, but we're not going to go with that. So if I wanted to solve for y would be basically opposite over hypotenuse. And so it would be 104 times the sine of 30, because that's going to be your opposite hypotenuse value. So let me just find out what that is on my calculator. I'm just doing this by hand next to my computer here, so you have to bear with me. Test this yourself. It should be the same. I got 52. So I'm hoping that's what you guys get as well. The x value will then be a cosine number, And so that'll be your hypotenuse gets multiplied up by the cosine of 30. So, sorry, I don't have my stylus pen, so you're gonna have to bear with my messy writing. If you don't understand what I wrote, just try to let me know tomorrow, and I'll see if I can do a better job of making it clearer. I guess rewatch, because I'll tell you what all these numbers are. This is 90.066 something, some really weird number. So let me try to plot those numbers over here. This guy here would be 90 basically, and this guy up here is 52. So using the little reference angle triangle, I was able to find some more side lengths. Well, I'm hoping you can envision this, because now, if I find a third color here, let's go with pink. Now there is a large right angle triangle that I could solve, and the hypotenuse of that large right angle triangle is actually what I was looking for. Okay. The distances then are going to be 90 plus 76. So that 90 plus 76 is going to be this side length, because you'll take the 76 you started with, and you'll add that 90 we just solved for. And then this side length up here is 52. So using Pythagoras' theorem, c squared will equal, you're going to have to square root when you're done 52 squared. And you're also going to have to put together that 90 plus the 76. Try to use 90.066, like use the whole number. And when you're done, you got to square root it all. So let me try this in my calculator. I'm going to take 90.0666 and I'm going to add the 76 on, which gives me 166.066, and I'm going to square it, which gives me about 27,000. Then I'm going to add 52 squared, which gives me about 30,000. And then when I square root the whole thing, I'm going to get an answer of 174 centimeters. And so that would be this distance right here, from the tip of the back of the chair down to the base over here should be 174 centimeters. You have to pardon me here. I'm not doing so well in our family today. A little sick today. That 174 centimeters that we solved for like that big hypotenuse, that's a very roundabout way of solving it. It's not very efficient whatsoever. So what I'd like to do is show you the cosine law. And so here's the cosine law. It's way faster. The cosine law is nearly the exact same as the Pythagoras' theorem, with one difference. There's like a little tag on the end, which has minus 2ab cos c. Basically, the idea is that if the angle that you have is 90 degrees, the cosine of 90 is actually 0 if you put it in your calculator, which means whenever you were working with triangles before, you were actually working with this rule. When your junior high math teachers taught you Pythagoras' theorem, they actually taught you the cosine law. But the cosine law for Pythagoras' theorem just means if this angle right here is 90, you don't need any of this stuff over here. And so we selectively in junior high just only ever give you right angle triangles just to make things simple. But now if you have a non-right angle triangle, so either like an obtuse or acute triangle, if you remember those terms, you just need to throw on this extra little bit. So using this law now and the previous page, the side lengths I had were 104 and 76, and the angle between was 150. So here's what it would have looked like. It would have been 150 squared. I have that right? No, 150 is the angle. It's 104 and 76. Sorry. Try that again. Go over here. 104 squared plus 76 squared. Okay, here's the new part. Now you still have to do 2 times 104, and you still need 76. And now you need the cosine of 1... Oh my goodness, I already forgot what it was. 150. Okay, when you're done all of this, don't forget to square root it. So try it in your calculators. I'm going to do the same thing. Well, hopefully you get a chance to do this. Minus 2, 104, 76, cosine 150. And then I got to square root all of that. Okay, I got 174.01. Okay. And if you can hear in the background, that's my daughter crying. So I'm going to pause my video right now, and I'm going to come back again, because I'm going to have to go take care of her. So I'll be right back. You probably won't notice the difference, though, because I'm pressing pause. Okay, I'm back. I have no idea where I left off. Sorry, I had to go take care of my daughter. Sorry, our whole family's kind of sick today, so. I think I finished off. This will seem weird to you because obviously it's like 30 seconds later for you, but it's been like half an hour for me. I think I finished off here by just finishing with the cosine law for trying to do this example right here. And hopefully I proved, if I did it correctly, that this distance across the hypotenuse was 174 centimeters. And if I used the cosine law, it was also 174 centimeters. So hopefully that's right. I'm going to try to get my mind back to where we were here. So ultimately, that's the point of this day here, is that if you have a non-right angle triangle, to solve that sort of triangle, the information you need basically is just like Pythagoras' theorem. You need to know c squared, a squared, and b squared. Well, you need to know a squared and b squared, so you need to know two sides. You're going to look for the third side. This side right here won't really be a hypotenuse anymore, though, because it's not a right angle triangle. It might not even be the longest side anymore. Okay. But the idea would be then that you plug that number in here a couple of times, and then what would have been 90 degrees is the angle between. So let me try another example here. This one here is a picture I found online. The idea basically is that like they measured an angle, so 70 degrees in the middle here, and they measured some distances, probably by walking or measuring it out somehow, 8.5 and 9 kilometers. And the question is, how far is it across Crater Lake? So hopefully you can see how this would be useful, because, I mean, measuring across Crater Lake might not be all that easy. Maybe it's not very practical to send a boat across. Maybe that little island in the middle there makes it tougher. So in terms of work here, it's going to be c squared equals, and then one of your sides is 9, so 9 squared. Another side is 8.5, so 8.5 squared. And then you're going to minus 2, bracket 9, bracket 8.5, and then the cosine of 70. Sorry, this is a mess. And then don't forget to square root it all. So I'm going to try throwing this in my calculator, see whether I can get the right answer here. 9 squared plus 8.5 squared, that's about 153. And then minus, and then all of this has to go together, so 2 bracket 9, bracket 8.5, bracket cosine of 70. So I got basically 100, and then when you square root that, I got 10.045 or something like that. So this would be 10.0 kilometers. And that makes sense in the context of the function. It sure looks like this side is the long side. I mean, this was not quite perfectly a right angle triangle. So if you did Pythagoras' theorem on its own, it would be close, but with this being a 70, that's why you need to have this extra little bit right here. So I hope that makes sense. Okay. Just a quick point here. What if the angle is the right angle? And I kind of mentioned this already. Then when you use the c squared equals a squared plus b squared minus 2ab cos 90, cosine of 90 is 0, meaning that all of this stuff becomes 0 and goes away, and so then it's basically Pythagoras' theorem. So if I didn't make that point earlier, make that point clear, you guys learned the cosine law when you learned Pythagoras' theorem, but just to make things simpler, we only ever worked with right angle triangles. Now our goal is to work with non-right angle triangles. And so basically you were working with this law the whole time. We just simplified it. So, here's a good example. This is similar to one of the questions we did in our previous unit, the idea of a bank shot. So this is like an absolute value kind of function, the idea of banking it. And so I give you some information. I say the pool ball travels for 17 centimeters before it banks, and then it goes from 71 centimeters from the top rail down to the pocket, and the angle is 36 degrees. So my question for you is, well, how far did the ball actually travel? Like straight line distance. Like if you could have shot the ball directly from here to the pocket, how far would this have been for a triangle right here? So see whether I can rewrite it again. So same thing, it'll be 17 squared plus 71 squared minus 2 times 17, 71 cosine of 36. And then don't forget to square root the whole thing there. So 17 squared plus 71 squared minus 2, 17, 71 cosine of 36. And so for that I got 3377. But don't forget to square root. So I got, when I was done, I got about 58.11. That would be that distance there. So, hopefully you guys can get the same thing. Again, I'm sorry that my writing is messy. I hope that you guys can follow. If you can't follow, we'll go over this again tomorrow. So if this is not effective, please don't freak out and be like, oh no, I don't know how to do it. Like, I'll go over it tomorrow if I need to. So it is pretty straightforward. It's a very, very straightforward rule. It should be written on your formula sheet, I believe. It's also written on, for you guys in my physics class, it's on your physics formula sheet too. So, this is a question that last year when I did this with my group of kids, we had huge debate over this. I've said to you guys before, I love finding real world scenarios to do math in. And so here's the scenario. Imagine you've got like a cattle gate and somehow a cow manages to like pry it open. But like not a lot, like 8 degrees. So like this gate is open by 8 degrees. My question is, how wide is the opening created? So if I can try to draw like a top-down view, here is where the gate normally would have been. And we'll call that 4.2 meters. Well, now the gate has been pried open by 8 degrees. Well, the gate itself hasn't changed, so this would also be 4.2 meters. And so my question basically is, could a cow squeeze through there? I mean, there's just a little bit of distance in there. Could a cow actually fit through there? And so really what we're looking for is this opposite distance. And this is kind of a unique question. I only gave you one side length. But really, where the gate used to be and where the gate has swung to, those are like those are the two distances. So you actually use the 4.2 both times. So we had a huge debate last year as to whether a cow could fit through here. I remember it was very what's the right word to use? Very highly contested. So let's try to solve this, and then you guys can debate yourselves as to whether or not you think a cow would fit. So it's going to be 4.2 squared. And then the other side is also 4.2. This is an isosceles triangle, by the way. Just the way the gate swings. 4.2, 4.2, and then cosine of 8. So, I mean, it doesn't swing open very far. The cow manages to nudge this thing 8 degrees. Could it fit its body through there? So 4.2 squared plus 4.2 squared minus 2, 4.2, 4.2, cosine of 8. And then when I square root the answer, I got, when I was like all said and done, I got 0.585 or so meters. So I don't know what the conclusion is. Do you think a cow could fit through about half a meter? So I don't know, for any of you kids who have perspective on that, I guess that's kind of the point behind why I'm doing this, right? Is I want to try to find a real world question to try to say, well, no, this does apply to someone somewhere. It could at least. So hopefully that made sense. Okay. Here's my one of my last examples here. We can also use the cosine law backwards. We can actually solve for angles. Okay. What if I give you all three side lengths? What if I told you that this side length here was 12 in a little triangle, this side here was 14, and this side here is 19? Now it looks kind of like a right angle triangle, but it probably isn't exactly a right angle triangle. So my goal here is we're actually going to solve for this angle right here and see what this angle actually is. And so this just means using algebra backwards to try to solve for the angle. So if I were to plug in numbers, normally I don't know c squared, but this time I do. I know the c squared actually is 19. I know that side across there is the 19. Then you've got to do 14 squared plus 12 squared minus 2, 14, 12. And then you need the cosine of c. And this angle right here basically would be angle C. So we could actually use the formula and go backwards and find what that C value is. So this is kind of tricky. We have to do this in the right stages. You actually have 4 different terms in this equation. Let me try to highlight them. Here is a term, here is a term, here is a term, and all of this stuff is a term. And they're terms because they're separated by plus and minus signs. So to get the cosine of C, like to get the angle by itself, here's how this is going to need to look. You're going to have to get rid of that 14 squared by subtracting it. You're going to have to get rid of this 12 squared by subtracting it. So this 14 squared is now on the other side. This 12 squared is now on the other side, and you've subtracted them. And so you could actually find that as a number. So I'm going to do that real quick. I'm going to go 19 squared minus 14 squared minus 12 squared. And all of that number there apparently is 21. Or so my calculator tells me. 19 squared minus 14 squared minus 12 squared. All right. Over here, 2 times 14 times 12, well, negative 2 times 14 times 12 is also a number. So if I go negative 2 times 14 times 12, that is the number negative 336. And you still have cosine of c. Just making sure this should work out properly. Then to get rid of the numbers in this term here, these ones you don't add or subtract, these ones you divide. So I'm going to need to divide by negative 336. When I go 21 divided by negative 336, you get negative 0.0625, and that is what cosine of c is. So then to get c by itself, you have to inverse cosine, which is like cosine minus 1 of that negative 0.0625. Sorry, that is a mess. That is the 0.625. So if I inverse cosine that, I get an angle, and boy, it is close to 90 degrees. But it's not 90. I got 93.6, basically, if I round properly. It's super close. This angle right here is 93.6. So, almost there. So, I hope that made sense. That's basically taking the cosine law and working backwards. Now, you can do that for any angle. The thing is that this 19 right here, the angle you solve for then is the side that is across from the 19. So if this side's the 19, we found the angle across from it there. I could actually rearrange all these numbers and solve for a different angle then. So like, let's say in red, let's say I wanted to solve for this little angle right here. Okay. Well, then I'd have to put the 14 here. Then the 19 and the 12 will go here. And the 19 and the 12 will go here. And when I solve for C, it'll actually give me this angle. So whatever number goes on this side right here, the side across from it, the angle across from it basically, that's the angle you're solving for. So you could actually do this process 3 different times and find all 3 of those angles inside there. Which ultimately is these last questions here. And I'm going to leave these ones for you guys to solve, I think. But my question now is solve these triangles. It's very similar to the first day we did where I made you solve triangles. Solving a triangle means find all 3 sides and find all 3 angles. So you could use the cosine law on its own just to find side C here, but then I also need you to find like this little angle right here and this little angle right here. So I like to leave that for you guys to try to solve. Take like 5 or 10 minutes, try to give it a try, see that you can make it work. Like work together in groups or work collaboratively. And hopefully you're able to solve the problem. We can look over it tomorrow as a class when I'm back again. So here's one to solve. Here's another one to solve. This one, all you get is angles that you have to solve for. So let me just real quick just make sure it's clear. If you want to solve for angle A right here, then you're going to go 8 squared equals 6 squared plus 7 squared minus 2, 6, 7 cos. I guess I could call it cos A rather than cos C just to make sure I keep things straight. So then bring the 6 to the other side, bring the 7 to the other side, make it all a number. This stuff here is also a number, divided away and inverse cosine to get that angle. So that's kind of the plan. Here's a formula sheet I found just online that basically kind of does the same thing, only rather than going like C, A, and B with this guy being C, sometimes they're written differently, and you could go with like B and B here and A here. So it's kind of the same concept. That's probably not the end of the world if you don't necessarily use these formulas like this. Last thought here. This video is pushing 25 minutes here, so that's about the right amount of time here for a short lesson like this. Here's a running tally of things to work on. I'd really like to recommend that you actually practice this a little bit before you do more of your assignment. So right here, I believe this last set of notes here, this is the stuff on cosine law, and it probably is worth your while just to try a few of these questions. I don't need you to do them all, obviously, but you may want to try a couple of them just before you continue on your assignment. When you do get finished, and you can probably take a break, so long as you come back in 5 minutes. So make sure that the sub here doesn't have to hunt you down in the hallways. But when you come back from taking a break at some point, work on these questions here, or maybe work on these questions first, then take a break, and then when you're done, work on your assignment. Like I said when I started this video, this assignment should almost be done before Christmas. I'm not actually going to make it due before Christmas, but my sincere hope is that you're nearly finished by the time we hit Christmas break, so that when you come back from Christmas break, you don't have a lot left to do. Be proactive. Don't procrastinate. Don't leave things till the last minute. If you actually want to be an actively engaged learner, you need to be on top of things and do them early. Doing things at the last minute means there's no time to get better and make improvements and make corrections. If you were to finish your assignment right away and call me over and ask me whether I take a look at it, I can help you make improvements. I can help you find your mistakes for you. We can help you get better. But if you're leaving it till the last minute, like the day before the unit test, then there's no time to actually improve. And that's kind of the point I want to go with here. So make sure you're proactive. Make sure you're working on it right away. Don't leave things till the last minute. That's never a good strategy. So good luck with the rest of class. I hope things go well. Make sure you save some questions for me for tomorrow if you have any. And yeah,